Okay, we're going to start chapter 4. Section 4.1 is about inverse functions. And there are three basic goals here. We want to identify if a function is one-to-one. We want to check whether two functions are inverses of each other. And then we want to be able to find an inverse from a table or a formula or a graph. So let's start with just finding an inverse. We need to understand what an inverse is and then find an inverse from a table, a formula, or a graph. We'll work on the other two goals a little bit later. So what is an inverse? An inverse is just a function that does the opposite of a given function, or it undoes the original function. So that's an informal definition, but it's an important one, and so let's write it down. So an informal definition would say that the inverse of a function does the opposite. It undoes the original function. And so let's have an example. If I tell you that the function f of x takes the input x and adds 4 onto it, then what do you suppose the inverse function is? If the original function adds 4, then the inverse function should just subtract 4. We have f of x equals x plus 4, then f inverse of x is equal to x minus 4. And so we can have a concrete example. If we let x equal 9, then what does the f function do? It adds 4 onto that. So we get 13. And so now the new function is supposed to do the opposite, or it's supposed to take you back where you began. So you see that we take the 13 now from f, the output from f, and we put it into the inverse function. We have 13 minus 4, and now we're right back to 9. So we started with 9, we did a process to get 13, and then we did the inverse process, or the inverse function, to get back to 9. Okay, and then let's look at this another way. I think back in chapter 2, I showed you something called a function machine, which is just a nice way to look at functions and how they work together. And so what we did is we took an input x into the f function, and then what comes out is f of x. Right, so that's the output from f. And now what we're trying to do is we're trying to have a new function g, so that when we take the output from f, we get right back to where we began in the first place, which of course is x, right? So what's the notation? So what we want is for g of f of x, right? That's the output from f going into the g function, to take us right back where we began, right back to x. And of course, there's a notation for that, which is the composition of two functions, which just says G circle F of X is equal to X. And that leads us right into the formal definition of an inverse function. And so it just says that let F be a one-to-one function. Now, we're not going to worry about one-to-one right now. We'll assume that our function is one-to-one, and then we'll get that sorted out. We'll get that piece sorted out a little bit later. G is the inverse of F if F circle G of X is X, and G circle F of X is also X. So the idea here, F circle G and G circle F, that just means that each undoes the other. It doesn't matter what order we do the two functions in, they each take care of the other. Okay, and then before we go on to the first example, I want to back up for just a minute, and I want to talk about notation here. And so there's the notation for an inverse function. You like my rainbow pen? I don't know if that's very good or not. Maybe I'll switch over to red here. How do we read this? We read F inverse of X. Right? So what's in the box here is read F inverse of X. And it's worth pointing out that you've seen some similar notation in a different context before. So there's another inverse. Let me say that a little differently. If I have 3 to the negative 1, then that's an inverse. But that's a different kind of inverse. That's a multiplicative inverse. That's called a multiplicative inverse. It just means that when you multiply 3 times 3 to the negative 1, you get back to the identity, which is 1. This guy, this new function that we're talking about today is not the multiplicative inverse, it's the inverse function. So let's write F inverse of X is not equal to 1 over F of X, right? This is the inverse function not the multiplicative inverse. So they're both inverses, but they're two different kinds of inverses. They're not the same. We use the same notation, that negative 1 up there in where the exponent would be, but it means two different things, and so you have to interpret it based on its context. To be clear now, F inverse is not 1 over F, right? And we can see that just from our first example, right? F is X plus 4. F inverse is not 1 over that. It's a subtraction instead. Okay, so let's go on and let's have a look at this first example here. We're going to talk about the function f of x equals 2x plus 1, and we're going to see the inverse 3 different ways. Let's start with a table. So in a table, we're going to write x, and we're going to write f of x is equal to 2x plus 1. And then we're just going to plug in some values. And let's see here. Let's do negative 1, 0, 1, and 2. I just made those up. You could choose different values. And then let's go ahead and finish the table. So 2 times negative 1 plus 1. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. I think this is going to be 3 and 5. Okay, and so now we're going to take this and we're going to use it to generate a new table. And the new table is f inverse of x. And we don't know its formula yet. We'll find it in a few minutes. But we do know points on that graph. So in particular, here, let's start at the bottom of the table. Let's start with 5. So if we put 5 into the inverse function, what comes out? Well, we know the answer because we can look at this table. If 2 makes 5, then over here 5 has to make 2, has to take us back where we began. And so you could fill in some more rows of the table. If 1 makes 3 in the original function, then 3 makes 1 in the inverse. And 0 makes 1, so 1 makes 0, and -1 makes -1 in both tables. Okay, so the big observation there is that in order to get f inverse, all we do is just switch x and y. To get f inverse, just switch x and y. Okay, so let's keep that in mind, and let's go on and let's look at the same idea in a graph. And so let's just plot the points for f of x. Let's plot -1, -1, and 0, 1, and 1, 3. 2, 5 is just about off of the graph, isn't it? I guess it's up about right there. And we might even want to plot one more point. -2 would make -3, wouldn't it? And then let me try this ruler here, and let me see if I can get it to make a nice straight line for us. Okay. And I can put arrows at the end of that, and I can label that f of x. And then let's go ahead and plot the points for f inverse and draw that graph. We still have the point at -1, -1. Now we have a point at 1, 0. And let's see here at 3, 1 and 5, 2. That is on the graph. And we could even go back out here to the left and find a point at -3, -2. Okay, and let's try to draw another nice straight line here through those points. Let's see here. Okay. And we can label that function f inverse of x. And then there's a nice observation to make about the relation between these two graphs. It could be a little tricky to see, but if we come in and we sketch the line, let's see here. If we come in and draw the line y equals x, then can you see that f inverse is a reflection of f over the line y equals x? It might help if you turned the page 45 degrees, or if you turned your head 45 degrees, you might be easier to see that the points in blue reflect over the red line to become the points in green. Yep. And the point that was on the line y equals x, there at -1, -1, it stays where it is. And then the point down here in blue and all of this section of the line in blue down here reflects up to make this line in green up here. Okay, so the big observation is F inverse is a reflection of f of x over the line y equals x. We want to remember that. And then one more thing, right? So we've seen the inverse in a table, we've seen it in a graph, and now let's see it symbolically. So to get F inverse symbolically, we're going to follow a little four-step process. So let's see here. Maybe I'll back that up just a second. So we're starting with f of x equals 2x plus 1. And then the first step is going to be to replace f of x with y. And so we'll write y equals 2x plus 1. And then the next step maybe is the most important. It's this observation that we made from the table. It says to get F inverse, all we do is switch x and y. So that's exactly what we're going to do right here in the equation. Is we're going to switch x and y. And so that will get us x equals 2y plus 1. And that is a formula for the inverse. Now what would you like to do with that formula? You would like to solve for y. So if we have x equals 2y plus 1, maybe we could just switch the two sides and write 2y plus 1 equals x. If we subtract 1, then we get 2y equals x minus 1. And if we divide by 2, we get y equals x minus 1 over 2. Or we could write that as 1/2 x minus 1/2 if we want to emphasize the fact that it's a linear function. Now we have it in the form y equals mx plus b. And then the last step is just to replace y with f inverse of x. Right, because that's the formal name for that function. So we could write our answer as f inverse of x equals x minus 1 over 2. Or we could write f inverse of x equals 1/2 x minus 1/2. Either way would be fine. So I'll put a box around both of them. And then the last thing I want to point out is that if we come back up to the table, you can check that this table is exactly the table you would get for this function. And if we come back up to the graph, this graph in green is exactly the graph of this function, of this formula. And so we have three different ways. We have a table, a graph, and a symbolic representation, a formula for the new inverse function.